Okay, so what I'd like to talk about, generally biofouling of ships, the impacts and the efficacy of management measures, but a lot of the talk will be about what we are now doing within the biofouling management expert group to try and answer a lot of the questions and move this issue forward. As you'll see, biofouling's been around for however long, far back you want to go, that people have been in boats, but I'll talk about that more as we go through. So, okay. All right. So what is biofouling? Okay, biofouling is basically you put something in the sea, things will grow on it. And if they're not wanted on it, well, it's biofouling. So it often relates to artificial structures, so ships and jetty piles and things like that, but you'll also have, you know, whales get, this got an arrow on it, I'm not sure, whales get the barnacles, turtles get the barnacles, driftwood get the barnacles, so really anything in the sea is the potential home for other species. And so most organisms in the sea that aren't biofouled actually have some mechanism to actually prevent things growing on their surface, be it chemical or physical or whatever. And you look at this, I keep using this quote, it's getting aged at the moment, but 10,000 years ago there weren't ships, barges, docks, floats and pilings. And the fouling community that we now find on ships is an assemblage of things that were, you know, one was picked up in the West Indies and one was picked up here and one picked up there. And basically they're species that are just have the characteristics to live on ships or like to settle on artificial structures. You know, some of the ones we have at the moment, there are barnacle species and some of the green mussels that only like settling on things that float. So they come up towards the surface. So you'll have barnacles growing all over the ships, but you won't find them on the jetty piles of these particular species. Here we go back to 412 BC, where arsenic and sulphur have been well mixed with cyan oil. They brought us back on my last voyage and the mixture evenly applied to the vessel's sides so that she may speed through the blue waters freely and without impediment. Arsenic stuck around until sort of the early to mid 1900s. 3rd century, the Greeks were using, so yeah, this is the thing, you put boats in the water, it's a happy home for something. And of course you go back to these days where to clean a vessel, they'd basically put it on its side on the beach and just scrape everything off, then apply the oil or the tar. So if we look at the cost of biofouling, most of the cost is actually involved in stopping it growing on ships. So we're a little bit vague there, but the paint and coatings market globally, 2015, $5.6 billion and projected to go up to $9.2 billion by 2021. In Australia, $16 million worth of anti-fouling paints sold every year. And this was something from Mike Schultz that estimated for the DG class in the US Navy, $56 million per year, or $1 billion over 15 years. So biofouling has a huge economic cost, and that's without calculating that the effect of biofouling on the ship slows it down, causes it to use more fuel. And this gets into the greenhouse gas emissions. So average annual fuel consumption by all ships, up to 300 million tonnes of fuel. And of course, every tonne of fuel essentially releases 3 tonnes of carbon dioxide. And the global fleet, I think it's, if you rank it, well, here you can see that 2012 it was, you're looking at 2.2% of the global input of CO2. So if you look where various countries come in, what they're contributing, I think shipping would come in within the top 10 countries with the amount of CO2 it emits. Invasive species. This is a sort of typical thing that you'll see, that there are an estimated 500 alien marine species in the US alone, around 200 just in San Francisco Bay, and some, you know, they talk about human health impacts, invasive seaweeds smothering seabeds, crabs roaming the seafloor, eating everything in their path. So invasive species have been something of concern since the, I can't remember the date Australia moved at the IMO to have ballast water managed, but I think it was in the 1980s. Now, special interest groups. I don't know how many of you in IMarEST are involved with special interest groups, but basically they're voluntary groups where you set up a particular topic on a particular topic, and people can get involved in discussions on that topic and also take issues forward and have the group actually, for instance, present information position papers. IMarEST is also a non-governmental organisation at the IMO, so we can actually present papers to the IMO as information papers. Currently, it is growing. The last, I thought I'd better update the slide. My last slide, I think, had 8 special interest groups, but now we're up to 20. 3, 6, 9, 12, 15, 18, 20, yeah. And some of the new ones, you know, they cover everything, alternate fuels for shipping, unmanned sea surface vessels, responses to marine pollution. One that has just started up is emissions from shipping. And as an IMarEST member, you can be involved with as many of these as you like. You can just sign up, and then you'll get communications to do with that particular group. And so we've got the Biofouling Management Expert Group. As I say, it was formed after the ANSPAC workshop in 2013, and our broad aim to establish a platform for a united way forward on the key international issue of marine biofouling management. And these are the key issues that we sort of identified, and I'll talk about more of them later, but effective management measures, biofouling management guidelines, in-water cleaning, regulation of antifouling coatings, and the impacts of biofouling and best practice management for ships. Now, the main way, or the most effective way, as I see communicating with people, is through the Nexus online network, which is on the IMarEST site. But once you're a member of IMarEST, you can go in and sign up to Nexus, and this is almost like a social networking site, but it's one that we can post things, you can provide feedback, and so we're using this as a primary mechanism for communicating within the our expert group, which is global in its coverage. So this is an example of the different groups that are there. Most of the special interest groups have their own Nexus site, but you can have Nexus sites for other things as well. So Vic Branch could have a Nexus site if they wanted to, and some of the other branches, though not needed because of the other things on the web. So we have this online, and here we have the biofouling management site. And you'd see at this stage, we've got 53 people who are a member of the Nexus biofouling group. And you can set up discussions. So here are examples of some of the discussions that we've got going on the site at the moment. So Roger Dyerberg, who some people will know, gave a presentation at the IMO PPR meeting last month, and Katrine has put up his PowerPoint presentation. Biofouling is also back on the IMO agenda now, with a push to have another biocide restricted the way the tributyl tins were. Alien species in the oil and gas industry, this is something that through our committee meeting, Jane Morrow from Brazil alerted us to, so we posted it there. We've got a list of biofouling meetings coming up this year. And here we go. This is an example once you get into pull up a discussion group. So a little summary of what's there. And we use this site from the workshop we had in September to post all the presentations. So we've got the discussion group here, and here are all the PowerPoint presentations that you can link into. So it's we see this a good way to actually communicate out there. Members of the actual expert group, we've got around about 160 members. It's hard to get good visibility of that because there's a confidentiality thing that when people sign up, they don't give permission for their email to be distributed more widely. So any communications I have with that group has to go across to IMarEST and they send out a letter or whatever. But I'm hoping to be able to shortcut that by getting them to send out saying, if you are happy to receive direct correspondence from the chairs, then please say yes, and we can get to all those people directly. The process of signing up to Nexus, there are difficulties with the technology quite often. And again, this week I had a very frustrated email from a colleague in the US who'd been trying to sign up and she couldn't get there. But once we put the message back to HQ, they signed her up and sorted it all out. But sometimes their IT is a little bit hard to work. So at the end of last year, we formed a committee, a small committee, to try and progress the work. It's sort of been sitting fairly idly, and apart from conducting the biofouling workshops, which we had in 2013, 2015, 2017, we hadn't been making many progress on some of the action items. So we set up the committee. I've got a co-chair now, Tom Vance at Plymouth Marine Labs, and we picked up a little bit of a spread of people. So we've got Colin Anderson on the paint side, Simon Bray in the UK, Jose Salas, who's in the shipping side, Jane from Brazil, and then we've got the three people at HQ. Maria and Bev are actually doing tag team on maternity leave at the moment. So Bev's still off and Maria's about to go, but so Katrina's sort of jumped in. So with this committee, we've now worked out that they can set up a WebEx meeting for us. Katrina will do that and we can all dial in, and it's working very effectively. Those who want to show their face, we can see, and it's a really good meeting, a way of doing things. So we'll be having regular meetings now to really push things ahead. So what we have, we put together a series of issues that we thought needed addressing. I think we've got 6. I'll run through them briefly, and as I go through each one, I'll give a little bit of a background to what's happening and why we have that one. So, environmental, economic and social impacts from introductions of marine non-Indigenous species associated with vessel biofouling. The IMO currently have guidelines for the management of biofouling on ships, but they're just guidelines. There's not a big uptake of them, and there are various pressures to make those mandatory, which there's a lot of resistance out in the industry. And what I think, for that to happen, you've really got to justify to them why it's being done, and it's not just a regulation. I'll talk about ballast water a little bit further on, but there's been long established views on impacts, but these are now being questioned, both in the literature. There's been a couple of significant books have come out where people have actually gone through the case and said, a lot of these arguments just stand up. And the evidence base, there tends to be a repetition of wildly exaggerated claims. So this is something we really want to look at. So ballast water, the Ballast Water Convention has now entered into force. This took a long time, but it's finally got there. So this means that ships will now have to fit a ballast water treatment system, which is something that as they take on board the ballast water, it has to be treated to kill anything in it, from crabs down to bacteria. And the standard is actually a discharge standard, so you just can't kill everything as it comes in and allow things to breed up. They port testing, and the ports have the say on testing. They test the discharge, and they can actually say yay or nay. Now, there's been an extensive program of the IMO getting different systems approved. Unfortunately, about 2 years ago, the US Coast Guard decided they didn't like the IMO one, so they'd set up their own, which was more stringent. And so you've got all these companies who had approved systems and ship owners who had started fitting them to their ships at great cost. Being proactive, actually might find that theirs doesn't meet the US standard. So a little bit of a mess there, but ultimately the intent was good and the outcome will be good. And if you look at this, this is Chad Hewitt and Marnie Campbell, who were down in Tasmania at the time. They're now in New Zealand. Had a very big, the CSIRO had a centre for research into introduced marine pests back in the late 90s and early 2000s. They did a lot of work, and they looked at all the invasive species in different parts of the world. So we've got Port Phillip Bay, so we've got the blue, and they looked at what was the likely source or the likely vector that brought those into Australia. The other one's San Francisco Bay, so it's a similar trend across, and you can see semi-dry ballast. So here we're talking about effectively the European crab that came in. Intentional aquaculture, so the Pacific oyster. Associates, so things growing on Pacific oyster shells, we've had a lot of those. Then ballast water and biofouling. So this is looking at the whole suite of all the species that are known from Port Phillip Bay that are not considered to be native and how they got here. These speckled bits mean that it could be either biofouling or ballast water. So you can see, you know, there's a lot of biofouling species there. So, you know, obviously it raises concerns. One of the big differences between ballast water and biofouling is that ballast water, you essentially, a ship's in a port, it pumps its ballast tanks full of seawater from that port. So you're taking everything. You're taking all the fish, you're taking the larvae, you're taking a subsample of that ecosystem. You then, ship goes to the new port and pumps it out. So you're releasing all of those species into what could be a new, you know, home for them. With biofouling, it's a more restricted process. As we said, the biofouling community is not a unique community. And with anti-fouling paints, you accumulate things with time, and it's quite selective. So some barnacles and the bryozoans, lace corals and some tube worms have actually, they've got a tolerance of copper. So they have a disproportionate proportion of those species will grow on copper anti-fouling paints. But they're not big competitors in the native world. Now, if you leave something long enough in a location and the paint loses its effect or there was no paint on, you end up getting almost the equivalent of the ballast water, because you get this big community, natural community developing of seaweeds and crabs and mussels and everything like that. And a good example of that was these pontoons came from Japan, and when they had the tsunami, they got dislodged and ended up coming ashore in Canada. And they're absolutely covered with a highly diverse community of species. So here again, you have a whole community moved from one place to another with the potential of it starting a breeding sort of cycle. So ballast water, you know, there's a very strong argument. And one of the things with ballast water is that it can carry the toxic dinoflagellates, the things that can cause the red tides and paralytic shellfish poisoning. So they can actually carry the cysts to a new port, they can take off in that new port, and also things that kill fish farms, things like that. So a lot of these parasitic type things or pathogens, which you don't tend to get on the hull fouling. And going back to that comment, that graph showing the biofouling, and these are the sort of comments that have come out, that vessels have been identified as the single most important vector for the dispersal of non-indigenous marine species around the world. More non-indigenous marine species introductions are attributable to vessel fouling than any other mechanism. The high relative risks for vessel types were commercial bulk carriers and container vessels. The highest relative risk vessel types are all commercial vessels, and the majority of biofouling, majority of risk. Now, what we're talking about here is you've got to get into the terminology, and a non-indigenous species is basically something that's not native to there, it's come from somewhere else. When you start to talk about the term invasive, that's generally been defined as something that causes harm. So it has to have some harm associated with it. So a lot of these things come in and they just live around the wharves and the piles and things, and they don't do anything. And it seems very rare that these species can actually penetrate healthy marine communities. If you disturb it, for instance, Sydney Harbour, some of the embayments up there are still contaminated with copper from industry. And if you do a survey of the biota in those areas, you'll find a predominance of non-indigenous species. Now, it's not that the non-indigenous species have caused the problem, it's just that the copper's killed off all the native things. So these things are the things that survive. So in many respects, they're actually increasing biodiversity by providing a community that can grow in an area and start to sort of remove the contamination or mitigate it. Now, on an international ship, every fouling species is a non-indigenous species on that artificially created, newly formed mobile island. A ship, what's a non-indigenous species in New Zealand is not necessarily the same as in Australia or Europe. The ship itself has it's an island. It moves from one place to another and picks up things. It has no native fauna or flora when it goes into the water. So its whole community is a non-natural community. And it's not new. Okay, this comes from the CRIMP report and shows when introduced species were first picked up in Port Phillip Bay. And you can see this big pulse here, and then after the 1950s it comes up again. Now, this is a little bit misleading because it has a lot to do with who was looking and how they were looking. This period of time we had a lot of naturalists out there which were fascinated with our marine, unique marine life. We even had he was the headmaster of Geelong Grammar, I think, who loved going out in a boat on the heads and dredging every weekend. And some of the seaweeds he found then, we've never found since. These magnificent things, and they're still in the herbaria, these pressed plants of stuff that he found. So there was a pulse there. And then this is when there was a big Port Phillip Bay survey where they actually went out and tried to actually document what was there. But in general, yes, it's been around for a long time. This species is actually one that I did my honours work on back in the Paleozoic, and we considered this was Australian native species. That's it growing down at Williamstown. This particular type of plant was found in Southampton, and that was one of the first records of a alien sort of spread of a non-indigenous species from Australia to the UK. When the world of molecular genetics came in, which actually found it's a Japanese species, it had already been spread to Australia. Similarly, this particular tube worm, which very, very common on ship hulls, as soon as the copper level starts to drop, the tube worm will come in. Described first, this particular species from Sydney in 1883. Now, lo and behold, it was also causing problems in the Bay of Naples at that same time, and I can assure you that it was unlikely to have got from Sydney to Naples in that era. So again, globally distributed now. This is the bit about the green crab. Comes from 1900 and talks about the old lumber ships, it's not a ship carrying lumber, but a timber ship, were attracted to our port in the early 1850s on the discovery of the goldfields. Many of these vessels were far from seaworthy, and they'd been patched up with false bottoms which had been riddled with teredo, shipworm, and were fouled with marine growths, affording ample shelter for the fry and young crabs on their long voyage, which would leave the ship on her coming to anchor. Not only that, but a lot of the ships that came out for the gold rush were deserted when they got here. So they were just left down off Williamstown, just sitting there. And in recent times, we had a similar sort of thing with a vessel that was forfeited to the Commonwealth, sat in Cairns Harbour for well over 12 months, and it was actually infesting the harbour with Asian green mussels, which had come in on that vessel. And this is all to do with the first pickup of that European green crab. They say fouling, it's also possible that it came in with the dry ballast. So they used to ballast ships by taking rocks off the shore crab in the rocks into the bottom of the ship. The crab can survive with very little moisture, just humidity. Get to Australia, take out the ballast, and its crabs go with it. If we look at history again, Woods Hole, the Bible of marine fouling and its prevention, 1952. They came up with a total of 90, they did a survey of fouling species, nearly 2,000 species. And on ships, they had 370. A more recent survey in 2010 in New Zealand comes up with 95 species on 270 ships. So they've been there for a long time, these things on the ships. In Australia, we have 11 species that have been argued as causing significant impact. And these are ones that they did a business case looking at what the impact was and was it, did they justify having a management plan? And if we look at them, okay, we've got the green crab, came in dry ballast, the Pacific oyster, which was brought in intentionally. These three species are all linked with being associated with the import of oysters or other species. So these are two seaweeds that actually grow on oyster shells, and their distribution in Australia is radiated out from Bicheno in Tasmania, which was one of the first sites of actual oyster farming. This particular species has been spread. It's an aquarium plant. Aquarium people love it because it grows so robust and it grows in the tanks. And ballast water, you've got the Pacific sea star, which is infested Port Phillip Bay, a little clam and the dinoflagellates. And then biofouling, we sort of come down to three species. This is the bag mussel, the European fan worm and the Japanese kelp. Both of these very, very common around our harbour here. Ecological impact. Okay, most biofouling non-Indigenous species tend to be confined to artificial surfaces and structures or disturbed environments. So here's a jetty pile down at Williamstown, and you've got this cloak of Japanese kelp. I remember once we were trying our little ROV, and we went down a pile and along the seafloor, and I think we covered one native species as we went, because we went from the kelp. There were other weeds. There was the European fan worm. We got onto the mud, and then there were the Pacific sea stars, and I think there was a sea squirt, and the mussel were the only native things there. I like this one. This is when they pulled all of these cars that had been dumped in the Maribyrnong River. And this particular one, I was riding a bike past, and it was absolutely just covered in European fan worms. It was the highest density I've seen. This is Hillary's Boat Harbour in Western Australia, and they've got a non-Indigenous sea squirt growing in there, which to date it's been found in just about all ports in Western Australia, but only in one place on a natural surface, which is in the Swan River. There's a little colony, and the fisheries people over there are studying this thing, and worrying about its impact in this part of the marina. Now, just look at that marina and look at what the original coastline would have been like, and think about what the impact of this particular species is compared to the impact of that harbour. And then you have these claims. This is the scientific dogma. Non-Indigenous species represent increasing global threat to coastal marine diversity. The macroalgae are responsible for some of the most serious biological invasions. Non-native species represent a biodiversity, social and economic threat. Invasive species are a major threat to biodiversity and can result in significant costs. Now, there's a guy published recently, a book called Fred Pearce, who's actually gone back and traced this, and it goes back to a one-page paper that someone wrote. And the confusion, this bit about non-native species represent an economic threat. The guy did a sort of back of the envelope calculation in the US, which came up with these $1 million, but most of it was crop diseases and weeds. And when you got into the aquatic species, they did talk about the zebra mussel in the Great Lakes, and even that's arguable whether it was a secondary impact or it came in because of the disturbance. This is one of these papers that was quoted. Here we go, 1992, habitat destruction foremost among the lethal forces, followed by the invasion of exotic animals. Habitat loss is the single greatest threat to biodiversity, followed by the threat of alien species. And then you have the most cited article ever published in Bioscience was one of these. And here's a recent review. The claim made a splash 20 years ago and became an object of veneration. People just quote it. Just about any paper on non-Indigenous species will start with this statement because it's a justification of the work without people going back. It's since been revealed as a canard that only die-hard true believers and the poorly informed continue to invoke. Most recent assessments of biodiversity defects demote invasive species to a subsidiary role. So there's a lot sort of to be clarified in this space, and within the BMAG we have got our first action is to seek and collate published evidence of environmental, economic and social impacts from introductions of marine NIS in the published literature, and attempt to document where impacts have occurred, identify the vector of introduction, and then consider species-specific management measures. Rather than saying all ships have got to do this, if you can find a species that's causing a problem, and I believe the biggest problem is the domestic movement of vessels, not the international movement. So a vessel going from Port Phillip Bay with all the Japanese kelp that's not well managed and goes to Portland or Adelaide is a greater risk than anything new coming from overseas. The incidences of new things establishing from international vessels, vessel fouling seems very small. Second one, I won't go through the whole thing, but this is looking at in-water cleaning. In-water cleaning is becoming more important because ship owners in CO2 emissions, if you do a regular hull clean, you will reduce the amount of fuel you need. And under the IMO emissions management, they're encouraging ships to do in-water cleaning. On the biosecurity side, the countries that are concerned about biosecurity are aghast at uncontrolled in-water cleaning. So we actually had in Australia virtually a total ban on in-water cleaning for many years. What are the advantages? And thanks to Eugene, there's a few slides I've taken from people at the workshop here. So these are all the advantages of cleaning, and the disadvantages: biosecurity and chemical contamination. So to proactively clean and clean regularly can actually get in before this. But New Zealand are doing a lot of work on establishing standards for in-water cleaning systems. Australia, this is the current Bible. It actually reviewed the old ban and actually now recommends cleaning and allows it under certain circumstances. So we had an example last year of some dredge vessels that had come into Port Phillip Bay. They sat, finished the work, they sat under Westgate Bridge for 10, 12 months. They were covered in growth, they need to go to Eden. So that met all the requirements for an in-water clean. It was locally established fouling, so there was no real biosecurity risk in cleaning it off there and then stopping it. The alternative would have been to have to take all of those vessels into dry dock and clean them. When there is a risk, if you've got an in-water cleaning system that can actually contain the waste, suck it off, filter it and hold it, then that is acceptable if there is some risk. And this is where the friend in Western Australia has got this EnviroCart, which is actually managing to do that. It actually captures all the waste, and it's been proven, pumps it up, puts it through a filtration system, and can go down to about 20 microns. So. And New Zealand, they're developing a testing in-water cleaning framework. Western Australia have already done this, and the US are down this path. So you've got all these people sort of working off on their own. PML are looking at what sort of approval process there would be in the UK, but we'd like to be able to have, again, some global synthesis. So we have here that our aim is to collate what's around at the moment and give some sort of direction and guidance. And Tom Vance in the UK is a strong lead on this. This is where we were actually doing this clean down at under the Westgate Bridge. It took a week for the divers to clean the 5 vessels. This is an issue, the balance between the efficacy and impact of biocidal antifouling coatings. Okay, to stop fouling you need a really good biocide. The best ones have now been banned because they actually killed other things. Regulatory agencies around the world are trying to clamp down on biocides, but as you do that, you lose efficacy. So what you have, and this is Gareth again from Denmark talking about that, you know, with anti-fouling coatings, you have the chemical laws, you have the biocide laws, and you have the emission laws, and there's no harmonisation. So, you know, you have, I remember at the IMO when they were looking to ban tributyl tin coatings, you had one working group in one room trying to get rid of the thing that was stopping all fouling and invasive species, and you had a working group in the other room working on ballast water on how to actually stop the invasive species, and it was interesting divide. And I used to give a talk called Anti-Fouling, where chemistry and biology collide, and it's trying to get that balance. But it's quite alarming that, you know, at the moment I think there's 400 paints registered in Europe, and if they take the biocide regulations the way some people want, they'll end up, I think it's about 10. And they're after copper, which is, copper is the, if you get rid of copper, we're in all sorts of trouble. And we don't have a lot. I mean, this is in Australia, we have 51 approved products because we have a very rigorous registration system which came post-tributyl tin. So you see here that most of the paints have either got cuprous oxide, or if you're for an aluminium hull, you've got copper thiocyanate. And then all of them have got a booster biocide as well. So just copper won't control everything, so you've got to have one of these things in it as well. Diuron is about to be banned in New Zealand, and you can see we've got a large proportion of our paints with diuron in it. But as seen here, our approval process for new products is fairly slow, it's rigorous. So products that we currently have that are allowed to use, of the 50 products, 25 had been approved prior to 2005, and some of them going back to 1995. We're using all these old technology paints because it's easier to grandfather or re-register an old paint than it is to get a new paint through the system. The promise is that you'll see here, we've got a little jump. And that's because largely APVMA have streamlined their process. It still takes up to 2 years to get a new product registered, but at least things are getting through now a lot faster since they developed an online portal. And again, you can see here that, you know, diuron's still the predominant biocide used, but these, this one here, copper pyrithione, is one of the better biocides around, and the zinc, which is green, and they're starting to have a greater influence. But of course, those coatings cost more, so to encourage boat owners to use them is pretty hard, particularly if you've got a small boat. So we're going to prepare a scoping document on this. We've got already a lot of communication happening between, you know, Colin Anderson, who with his career in anti-fouling paints, and to try and come up with, you know, how the balance should work. Management policy text review, okay. New Zealand have developed their own biofouling management policy. Australia's still working on one. California set about writing one, thought they had it through until the ship owners saw it, and it took another nearly 10 years until they finally got it through, which they have now, and very toned down what they proposed. New Zealand have actually implemented this risk management fouling, which from May this year applies to all vessels entering New Zealand. But we as a subgroup are looking at being able to provide a review of text to actually look for the holes and relate it to practicality and see how it goes. Modified ship design. Okay, this is something that causes a big problem in this area of biofouling. Anzac class ships, intake gratings are about this big. Once the ship's built, you can't get in to repaint the Seachest, which is a cavern. That particular photo was taken where we had an incident of, we thought was an exotic mussel come back from the Gulf. And that photo was taken by the cameraman, had his camera, and he could get his hand up through the grate and click the shutter. And that's what he saw. It was absolutely choked with mussels. The old Sea Road Mersey, that had a fouling prevention system in it that dripped an anti-fouling chemical at this side, and the intake here, now you can see the mussels just fed on it. And the standard sort of square design of a Seachest, this little pipe here is actually, it was up in Singapore, it's choked with Asian green mussels. So the old Navy design was, you need your box as big as possible so that if you get any mussels in it, the water can still get through and you're not going to impede it. But of course, then it becomes a little sheltered haven for everything. And thanks, Richard. I've pinched a slide from one of Richard's presentations where he was looking at designing a Seachest insert that you could put in, which better funneled the flow, so reduced the fouling. And you can see here's just a square simulated Seachest, and here's one that's actually designed as a funnel. So it means that there's virtually no chance of things settling inside it. Here's some other ones. You know, these little copper anodes are meant to be preventing growth on these plates. One I showed you before. Here's a box cooler, which are horrific things as far as fouling goes, because they're just like a car radiator suspended in a Seachest, and they get absolutely covered in growth. And again, here's inside a Seachest of a cruise vessel that actually had one of these marine growth prevention systems, and we've got whelks, we've got big barnacles, we had crabs, we had everything. So there's a lot of design work needed to actually get these things up and running. So it's part of it is, you know, the BMEG is going to look at a way of sort of developing a case to move things forward. One of the things is that ships are now on 18 months, they're going up to 7-year docking cycles, some of them. A ship's life is perhaps 15 to 20 years. A lot of these new commercial ships will only dock once in their lifetime. So if you're looking at changing the design of something, and if you think of nothing has been developed now out there on redesigning Seachests, so how long before that will actually be incorporated into a new vessel? I mean, we're looking at a long time frame. So it's it's really something that I think that a lot of this issue on biofouling has stayed in the wrong subcommittee at IMO. It should have gone out of the Marine Environment Committee and gone across to the design subcommittee to try and get things moving. So at the moment it's all reactive rather than proactive. And finally, a best practice guide, providing advice on the best way to manage your fouling. I had a very productive meeting in the West recently where one of the offshore companies is looking at getting a new vessel where they don't want any growth on it at all. And so we sat down and we looked one particular coating for the hull, a different coating for the propellers and the Seachests, a definite mid-term docking cycle, electrochlorination, marine growth protection system, and basically everything we said, just tick, yes, we'll do that, 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 because they are so concerned with largely the state regulations. So biofouling management guidelines gives good guidance on general things to do. So it says things like install an appropriate antifouling, but they really don't tell you anything about what is an appropriate antifouling. They'll say, have a marine growth prevention system, but we've shown that some of them just do nothing. All the ship owners doing is wasting money on copper. So it's to try and sort of get beyond this. As a start, part of the guidelines has a requirement for a biofouling management plan, and we worked in with the International Paint and Printing Ink Council, IPIC, their antifouling working group, to actually develop a template for this, which is now available. So any ship owner or operator can pick up this template and fill it out. So collating things and technologies to get a best practice. Some of these things at the Oceans Conference last year, they were calling for environmental commitments. And through the IMarEST, we've actually got some of our action items in as commitments under the Ocean Action Plan. So to look at the impacts, to look at in-water cleaning, and to produce guidance documents. Glow fouling, that's slipped a bit going to Apple, but IMO are about to start a glow fouling project. They had a glow ballast project where they provide support to developing countries to be able to give them the understanding to be able to implement these policies, and they've planned a glow fouling one. And we were lucky to get two of the people who were responsible for this down to the workshop in September. So it's building partnerships to assist developing countries to minimise the impacts of aquatic biofouling, and based on glow ballast and glow meat. So they have this sort of tiered in the way they do it, and when you get to the actual way they do it, you have input for technology and cooperation on all of this. And we're going to be involved directly with them once they get it up and running. We actually had a WebEx meeting with John and Antoine last week, which again IMarEST set up, so it worked really well. We had the two of them in the IMO building, and then Tom down at Plymouth and myself out here. And they're very keen on doing these partnerships, but they're still 6 to 12 months away from getting anything going. So we're actually hoping to try and get a bit of money from them so it can support the work, so we don't have to do it all ourselves. And that's one of the issues we're having, finding different avenues for getting money, but we're working on that. So yeah, project launched later this year, where IMarEST are already official strategic partners. We've had the BMEX discussions, and there's quite a few synergies, and particularly they're keen they have these global R&D forums, and they'd like to do something like with the workshop we had in Melbourne, so actually to get us to sort of be involved in doing one of those overseas. And we've suggested Singapore is probably a good location. And that's it. So thank you for your time, and I'm happy to take any questions whatsoever, but fairly broad-based, just give an indication of what we're trying to do to fill the gaps.
John, in terms of the Seachest, fouling in heat exchangers,
yes,
further into the ship or submarine, Has there been any work done in experimenting with different metals in the periodic table to determine what is hostile to marine growth and could inhibit? I mean, you mentioned
Yeah, well,
chlorination and
cupronickel, when I was working with GSTO and we had big problems in the Oberon class submarines, and they had 70-30 cupronickel pipework. We did some work to show that 90-10 would be a little bit better, but it does, in use, it tends to get that oxidation coating, so you don't get the continuous release of copper. The best thing is design. At that time, you know, we had all the problems on the Anzac class, but the Fremantle had nothing because their cooling systems were very short systems. They tended to take the water in through an exchanger which would cool a coolant and then put it out. So if you have a straight run pipe, you don't tend to get fouling in that because the water flow controls it. The Anzacs were a disaster. They had about half-inch pipe, seawater pipe, going up to cool the radar, and you get one barnacle in that. And apparently we also had a lot of problems with the mine hunters, and I can't remember one, but a marine growth prevention system was offered with the mine hunters, and someone in Canberra said, no, we don't need that. And then we had all these problems. I mean, they were almost declared unseaworthy because we had pipework was actually corroding through within 6 months. And we had the hull isolation valve actually full of growth and getting microbial corrosion behind it. But turned out one of the biggest problems was actually the cathodic protection system. And there was stray current actually going from where there are anodes around the propeller, jumping around into the pipework and then jumping across the bellows into the internal system. And where it jumped out, you got corrosion. So the end plates of the stainless steel were actually corroding through. But the Anzacs were designed in Germany. They don't have the same fouling problems there. Yeah, so it's, and it's something that, you know, everyone, Cathelco have sold a hell of a lot of units on dodgy science. I mean, it's, and I've seen, you know, I did a project for New Zealand looking at these systems, and just about every Seachest that, you know, they religiously replace their anodes, but you see all this growth. And I've got a picture of a big sea suction strainer on a tug, which was about this diameter. And the lid, the copper anode was attached to the lid, and they'd lifted the lid up, and there's this beautifully eroded anode working perfectly. And I have never seen so many Asian green mussels in the strainer basket. It was green with these mussels. But, you know, they just hold set at this. And I ended up talking to one of the guys who worked for Carnival Cruises from Norway, and they'd been using this system, and he'd been alerted for something I said, and he was here for the Melbourne Cup. We had a meeting because, you know, all the Carnival cruises come in for the Melbourne Cup, and he said, we've always suspected this, but my job's just to ensure that the electronics are right and that they're getting the setting that we're told. And but it's dodge. Even the, you know, the
message there, it's actually encouraging growth.
It can. On the Oberon submarines, it was. The little bit of copper that was releasing, the particular tube worm has got what's called a hermetic effect that copper can promote its settlement. And we did a trial inside the subwharf where we were dosing at different levels of copper, and we had the plates with no copper, then we had a little bit, and then more and more. And there was more growth on the one with a little bit of copper than the one with no copper. And then you got a medium amount of growth, and then we had to increase the dose 10 times. So they would say 10 parts per billion, and you had to get up to about 100 parts per billion to actually stop the growth. So the Collins arrived, and the first one we looked at, Cathelco had said set as required. The first boat I looked at was on the hard at Adelaide, and there was green water coming out. They'd gone from one extreme to the other. So I'm a fan for electrochlorination. I think that's where you generate the hypochlorite. I think that's a a much better system.
It's all right while it's working, but if it stops and then turn it back on, all that crap.
They're the issues, yeah. And there was a problem at one time with getting replacement anodes in Victoria, one company, and the Sea Road Mersey, for instance, had initially had an electrochlorination system in. They'd ripped it out and put this dosing system in, which they said, we're happy with that, and you saw the muscles. And it's, and again, which boats were they? Was it the Armidale class, where we talked them into doing electrochlorination, and they bought a system from Italy, where apparently they had a very nice young saleswoman over there who spoke really good English, and then they got them installed, and there was some sort of fault with the non-return valve or something that was shutting the systems down. They got back on the phone and she'd left, and they couldn't find anyone who they could talk to. I mean, it's just comedy of errors in these things. The whole theory behind the electrochlorination, and it's used very extensively. There's sort of Chloropac and electrocatalytic in Wales that build these huge units for the oil and gas industry. And you're not having to replace anodes, and as long as your system is set up to be reliable, the fact that you're generating salt, it's like a saltwater pool. I mean, the theory's there. Like the chlorine will kill the things, whereas the copper, you know, we've got the copper anodes, and you'll have tube worms growing around the base of them, and they're saying, well, this is working. Or, you know, you think an anti-fouling paint, you get a split in the paint, and you'll get stuff growing there because the copper has no throwing power, and yet you're expecting this anode sitting like this in the top of a Seachest to be stopping growth in the engine system. So it's, yeah.
You also have the issue of actually copper plating, like work in the heat exchange and stuff, when you ran them up too high.
Yeah.
So you start depositing copper through the system.
Yeah.
And wreaking havoc in that way as well.
Yeah. Yeah. No, after I published the New Zealand report, I had a very acerbic email from a guy in Cathelco in the UK and said, well, that wasn't our system and that wasn't working right, and and I went back and said, that was your system, that was working right, and I didn't hear anything more back from him.
So you're not on their Christmas card?
I'm not on their Christmas card list, no. Some years ago, when we were doing the stuff for the Oberons, we had some really constructive conversations with them. And they had a guy there at the time who was saying that a combination of copper and chlorine actually works better than either on its own. It was called the BFCC system, but that never sort of went anywhere.
How's that regarded by the environmentalists?
Chlorine is a concern in some areas, and the electrocatalytic actually design a dechlorinator that assesses the concentration of free chlorine in the discharge, and will actually put in something to remove that chlorine. So it depends where you are. The US, again, very concerned with that. Hawaii, they have on pier side electrochlorinators. The other thing with electrochlorination, you can do a pulse dose. You don't have to have it continuous. You can just pulse it several times during the day. But yeah. But all of this just doesn't get out to industry. You know, the shipping industry, they just have salesmen. Too many. Yeah. Okay, thank you very much.